Every program we've written so far runs in a straight line. Each line executes once, top to bottom, with no way to skip, repeat, or choose. Branching changes that. A program takes one pass when a condition holds, and a different pass otherwise. Branching is built on Boolean values, so we start with comparisons. First, a distinction that trips up nearly everyone. A single equal sign is assignment. It binds the value on the right to the variable name on the left. It makes something true by force. A double equal sign is completely different. It's a comparison for equivalence. It asks Python a question. Are these two expressions equal? And the Python answers with a Boolean, the value true or the value false. One symbol gives a command. The other asks a question and gets an answer. Confusing the two is one of the most common beginner bugs. Expressions don't have to produce numbers. They can produce Booleans. Type 2 less than 3 into Python, and it evaluates to true. Type 2 is equal to 3, and it evaluates to false. Python has a full set of comparison operators, and everyone returns a Boolean, double equals test equal to, exclamation point equals test not equal to, less than and less than or equal to, greater than and greater than or equal to. Each one takes two expressions, compares them, and hands back exactly one of two possible values, true or false, nothing in between. These operators work on strings too, with one catch, case matters. Compare the string lowercase a against the string uppercase a with double equals, and the Python returns false. Lowercase and uppercase are different characters, so the strings are not equivalent. If a user types their name with different capitalization than what you stored, a direct comparison fails. Keep this in mind whenever you compare text. Equality on strings means an exact character-for-character match. Once you have Booleans, you can combine them. The word not flips a Boolean. 2 is less than 3 evaluates to true, so not 2 less than 3 evaluates to false. The word and joins two Boolean expressions. The result is true only when both sides are true. If either side is false, the whole expression is false. Test it. 2 less than 3 and 3 less than 4. Both sides are true, so the result is true. 3 greater than 4 and 3 less than 4. The first side is false, so the whole thing is false. You never need to memorize truth tables. Test any combination directly in Python. The word or is the mirror image. It's true when either side is true and false only when both sides are false. So you need just one true input to make an or expression true, one language warning. In Python, you write the actual words and or not. The ampersand symbol and the vertical bar symbol mean something different. They're bitwise operations that work on the individual bits of a number, and they'll give different results. If you're coming from Java or C++, where those symbols mean logical operations, this is a common trip-up. Use the words. Let's work an example with variables. Set time to 15, the hours a problem set takes. Set sleep time to 8. Now print sleep time greater than set time. Python substitutes the values. Is 8 greater than 15? No, so it prints false. Booleans can also be stored in variables directly. Set derive to true and drink to false. Now compute both equals drink and derive. The and needs both sides true, but drink is false, so both gets the value false. Print both and you'll see false. Variables holding Booleans behave exactly like variables holding numbers. You can store them, combine them, and pass them around your program. Now a small interactive program. Store a secret number. Secret equals 5. Then read a guess from the user. The input function prompts please guess a number and returns whatever the user types. Wrap that call in int to convert the text into an integer and store it in guess. Finally, print secret is equal to guess. If the user types 5, the comparison evaluates to true and the program prints true. Any other number prints false. 3 lines. Store a value, read a value, compare them. That comparison result is exactly what a branching statement will consume later. That int conversion hides a subtle bug worth understanding. The input function always returns a string. If you skip the cast, you're comparing the integer 5 against the string 5. To Python, an integer and a string are different types of objects, so they can never be equal. The comparison returns false every single time, even when the user types the right number. The program runs without any error message. It just gives a wrong answer silently. Experiment with this yourself, remove the inticast, type the correct guess, and watch false appear. Silent type mismatches are among the hardest bugs to spot. Booleans are the foundation of decision-making in programs. Comparisons turn questions into true or false answers. The words and or and not combine those answers into richer conditions. And those conditions let code express logic the way we do in plain language. If this is true, do one thing, otherwise, do another. That conditional structure, driven by a Boolean test, is what makes branching possible, and the branching is where programs come alive.